Hello student, hi, good evening. So today we are going to discuss about diagram of electrical system. Okay, so we are going to discuss about block diagram of electrical network. Okay, so block diagram of electrical network. So now see block diagram. So this is what about block diagram block diagram of electrical network. Okay, block diagram of electrical network and signal flow graph or and signal flow graph signal signal flow graph signal flow graph for electrical network. Okay, how to represent signal flow graph and block diagram for electrical network. So now see, I am taking one simple RC circuit. Okay, so this is my RC. See here, this is my RC circuit. Okay, so RC circuit. So this is my RC circuit. Now in signal flow graph, this is my R, this is my C, and this is my input Vi positive negative, and this is my positive negative output. Okay, and this is ground. So now see, if I want to convert this into signal flow graph. For converting the electrical network into signal flow graph, first of all, we should know that how to convert this into signal flow graph. For that, we have to first of all see, we have to count how many number of electrical element is there. How many electrical element is there? One, two, one, two. Every electrical network, every electrical component represent one variable. Okay, one variable. How many variable is there? Two variable. Okay, two variable. How many component? Two. So number of variable is equal to number of electrical component. Okay, and this variable is represented by, see here, number of variable here is what? Variable implies number of variable is equal to what? Variable implies what? Electrical component. Okay, component. So number of variable, we can see that number of variable is equal to number of electrical component, and this variable is denoted by what? Single node. Okay, single node. So each variable here, variable is denoted by what? Node. Variable in electrical network, that is nothing but node in block diagram. Okay, so node in signal flow graph, this variable is represented by node. Okay, represented by node in signal flow graph. Now see here, variable represented by node. Okay, so node, variable represented by node, and this variable is nothing but electrical. This variable is nothing but electrical element. How many electrical? Number of variable is equal to number of electrical component. Now see here, how many electrical component is there? Two. So just write two node. Okay, so these are my two node, and except what? Reference node, that is what? Input node. Okay, so including input node, how many node is there? Three. Okay, so except input, how many number of node is there? That many number. How many number of electrical components? How many? One, two. Then two node. Except input, for input you have to provide external node. Okay, so this is my input. Right here, input vi. Okay, and output is what? V naught. Okay, and every node is represented by what? Every node is denoted by either current and voltage. You see here, I am representing this what I1. This is my I1. Okay, this is my I1 and this is my voltage V0. This is my voltage V0. So therefore this node, this is Vi, input Vi. Okay, and this node is nothing but I1. What? I1. This is my I1. Okay, and this is my output node V0. Yes, V0. If you see here, this is my I1 node, I1 node, and this is my V0 node, V0 node. Okay. Now just now write equation here. I1 is equal to what? I1 is equal to Vi minus V0, V0 divided by R. Okay. Write it separately. Vi by R minus V0 by R. Yes, V0 by R. Now, and V0, this node is V0. V0 is equal to what? V0 is equal to this. Okay, voltage across this is how much? Current into impedance. Current is how much? I1, and impedance of capacitor, that is nothing but 1 by SC. Okay, this one 1 by SC. Now see here. Now just fill this signal flow graph. This is I1. I1 is how much? Vi by R. So Vi by R means 1 by R. 1 by R. And V0. V0 by R. It is going like feedback to I1. How much? Minus 1 by R. This is minus 1 by R. Now come to V0. V0 is I1 by SC. Means I1 by SC. 1 by SC. 1 by SC. Okay, so this is the way to represent this electrical network through signal flow graph. Okay. Now this is the way. Okay, and in block diagram, if you want to represent in block diagram, then this is my Vi. Okay, just give this to summer, this. Okay, summer, and here this is my forward path, and here this is my forward path. Gain is 1 by SC, 1 by SC, and this is my V0, and this is my feedback. Feedback is how much? 1 by R, 1 by R, and this is my negative feedback. Okay, so this is my way of representation by block diagram, and this is my representation in signal flow graph. Okay, so somewhat I want to represent this above, so it is not visible down. See here. So this is my block diagram. This is summer. Okay, and this is my summer, and this is my block of 1 by SC, 1 by SC, and this is my feedback. Feedback gain is how much? 1 by R, and this is my negative feedback, and this is my V0. Yes, so this is my Vi. Okay, now see, and this gain is here from Vi. This is my, let's say, Vi, and this gain is 1 by R, 1 by R. Okay, so there is also block of 1 by R, 1 by R. Okay, 1 by R. So this is what representation. How to represent? Just what you have to do, just count the number of electrical component. How many? 1 and 2. Okay, that many number of variable is there. How many number of variable? 2 variables. Except input. For input there is a separate variable. Okay, so separate variable. Total is 3 variable. Total is 3. Okay, so this means these are 2 variable. Okay, electrical component. 2 electrical component, 2 variable. 2 variable means 2 node. 2 node. Okay, 2 node. And for input separate node. Okay, separate node. Then after that you have to write the equation for current I1 and for V0. Okay, in this way, once you will write the equation, then after that you have to fill this signal flow graph. Okay, so now see, you will get it. So you will get it in better way by taking 3 variable or 4 variable network. Okay, so now it become easy after doing 3 variable. Okay, so then you will understand properly. See here, for 3 variable, for three variable. So let's say I am taking here my resistor, okay, and this is my, let's say, capacitor, okay, and this is my, again, resistor, and this is my, let's say, inductor, okay, inductor. Now see, this is my output V naught, and this is my input Vn. This is my R1, and this is my C, and this is my R2, and this is my L. Okay, and let's say somewhere this is my ground. Okay, now the question is how to represent the how to represent this network through signal flow graph and block diagram. Signal flow graph and block diagram. First of all, we have to mention here current and voltage. Okay, current and voltage. Let's say alternatively, this is my current I1, and this is my voltage here V1, then current I2. Okay, so then this is my current I2, and this is my voltage V0. Okay, so you have to what? You have to represent alternatively current voltage like this. Okay, current voltage. So now see here, how many number of electrical element is there? One element, two element, three element, four element. Total is four element. Okay, four number of element means how many variable is there? Four variables. How many variable? Number of variable is equal to how many? Four variable. Okay, four variable. Then number of node is how many? Number of nodes. Then this is first, number of variable is equal to 4. Okay, so node is equal to how many node? Node is 4. 4 number of node. Yes, 4 number of node is required, and each and every node is represented by what? Current and voltage. Node represent either current and voltage. Okay, so now see here, let's say represent these four node. See here, I am taking one node, then second node, then third node, okay, then fourth node. Okay, four node I have completed. Okay, four node, and here separately input node is separately we are taking one input node. Okay, so these four are separate. Okay, except this we are taking input node. Okay, separately. So this is my input node. Now see here, this is my input is what? Vi. Okay, then there is a gain. Okay, so gain. Now after that, second node is what? I1 right here, I1. Third node is what? V1 right here, V1. Fourth is what? Fourth is I2 right here, I2. Fifth one is what? V0 right here, V0. Okay, actually these are four node we are taking. Okay, for input we have to take extra, we have to take separate node. Okay, so total node is actually four. Four element, four node. Okay, we have denoted this by current and voltage alternatively. See, voltage current, voltage. Yes, voltage current, voltage. So now for how to fill this signal flow graph, first you write this equation. First, for current I1, first node I1 is equal to, from here, how much? V1. How much is this? Vi minus V1 divided by R1 is equal to what? Vi divided by R1 minus V1 by R1. Yes. Next node is what? V1. Right? V1 here. How much? V1 is how much? V1 is equal to I into R. I into R means this current. This current is how much? Difference of this I1 minus I2. Okay. So then V1 is equal to I into R. That is I1 minus I2 into R. Into R is what? 1 by SC. 1 by SC, which is nothing but I1 by SC minus I2 by SC. Okay. Now Next, next node is what? I2. I2. Right, then I2. I2 is what? I2 is equal to how much? I2 is nothing but V1. V1 minus V0. V0 divided by R2 is equal to what? V1. V1 by R2 minus V0 by R2. R2. Okay? These are four nodes. And fifth is what? V0. See here, fourth node. This is first, second, third, fourth is what? V0. V0 is equal to what? V0 is equal to, see here, from here. V0 is equal to what? V0 is equal to I into R. I is what? Current I2. Current I2. So this is nothing but I into R. I2 into R is what? SL. SL. Okay. So these are my four what? Node. Four node equation I have written here four node equation. Okay, four node equation. Now we are going to fill this. Okay, first one is what? I1. See here, I1. I1 is what? Vi by R1. So means Vi by R1, 1 by R1. Okay, so next is minus V1 by R1, minus V1 by R1. That is what? Feedback. Feedback. See here, how much? Minus 1 by R1. Minus 1 by R1. R1. So next is V1. V1 is how much? I1 by SC. So I1 by SC. This is my 1 by SC. 1 by SC. Then V1 is minus I2 by SC. Minus I2 by SC. See here, minus I2 by SC. Minus I2 by SC means 1 by SC. Yes, I2 by SC. And then after that I2. I2 is what? After that I2 is what? I2 is V1 by R2. V1 by R2. So means 1 by R2. Then minus V0 by R2. Minus V0 by R2 in feedback. In feedback. Minus V0 by R2. V0 by R2. R2. Okay. This V0 by R2. V0 into minus 1 by R2 is nothing but minus V0 by R2. Similarly, V0. V0 is how much? I2 into SL. So I2 into SL. Okay. So this is what now. This is nothing but this is signal flow graph for this electrical network. Electrical network. Okay. So now, if you want to represent, this is my signal flow graph. If I want to represent this by block diagram, this is my Vi. Okay. And here is my summer. And this is gain of 1 by R1, 1 by R1. Okay. Then after that, here is my forward path, 1 by SC, 1 by forward path. Okay. So forward path is what? Block 1 by SC, 1 by SC. Then after that, there is what? Summer. Again, let's say this is my summer. Okay. And here this you can represent. Okay, so just wait. Dot. Yes, so this is my, let's say this is my summer. Okay, and this is my next one is 1 by R2, 1 by R2. Okay, and this is again feedback. This is feedback from here to here. How much feedback is this? Negative feedback. Negative feedback of 1 by R1. Okay. Similarly here, this is also here feedback. Feedback how much? 1 by SC with negative feedback. Negative feedback. So then here, this is 1 by R2 and here also summer. And this is my gain of what? What? Gain is SL. SL. Okay. SL. And here, this is my SL of gain. Okay. Then after that, this is my V0, and this is feedback gain of 1 by R2, negative feedback. Yes. So this is my block diagram. So this is my V0. Yes. This is my signal flow graph, and this is my block diagram. Block diagram. Okay. So now in this way we have to what? We have to represent what? Electrical network. What is the procedure? Just you count first how many number of element is there 1 2 3 4. Then that many number of node. How many? 4. So 1 2 3 4. And for input separate node. Okay, you have to take separate node. Then after next is what? Next procedure is next procedure is what you have to write equation for each node like I1 node equation is what? This I1 is equal to v1 minus v1 vi minus v1 by r1. Okay, so next is what? v1 is equal to I1 minus I2 by sc. Okay, so then next one is v0 is equal to I2 sl. Then after that you have to fill this signal flow graph from here like this: vi by r1 minus v1 by r1. Okay, so one is feedback, forward feedback. So what is there? See, this 1 by r1 is what? Admittance. 1 by c is what? Impedance. 1 by r1 is 1 by r2 is what? Admittance. SL is what? Impedance. This is admittance, impedance, admittance, impedance. In feedback also, see here, admittance, impedance, admittance. Okay, so now I am going to give you shortcut. Okay, so this is what general process. This is what general process. Okay, so but during exam, okay, so in exam we don't have that much time to write first equation. Then after that we have to show what? Signal flow graph. Okay, so we don't have that much time. Now we are getting some idea. What idea we are getting? We are getting the idea that the branch gain is nothing but either it is admittance or impedance. Okay, if you see in cascade, see here, admittance, impedance. Similarly, feedback. You see feedback alternatively it is changing. Like here you see admittance, impedance, admittance. Okay, so now I am going to rub this. Okay, I'm I just I will just try it to write directly. Okay, so without this procedure, and I'm assuming myself in examination hall. Okay, you just assume yourself that you are in examination hall, so that time you will not get this much time to solve. Okay, so this much time to explore all the things. Okay, so then after that, what is the best idea is what observation you can make from here, so that you are able to write the signal flow graph for this network direct without writing any node variable, nothing. Okay, so just it will come by practice. Once you will practice, definitely, then after that you can write. So how you can write? So that idea I'm going to give you here. Just you see the network, what idea we have got, that there is a alternative, the cascade. If you see in cascade, there is what? Gain is what? Alternate gain in the form of impedance, either impedance, admittance. First it is admittance, then impedance, impedance. How much long network is this? Okay, so no problem at all. So also alternate current voltage. Okay, so like that. So now see here, this is what? How many node? First you just write the node one node, two node, three node, and four node. Now in this four node, and here for input there is a separate node, vi. Okay, vi. Now after that you can directly write. Okay, so without seeing also, what is this node? I1 alternate. You see, this is my voltage, then definitely this is current. So this is I1. If it is current, then it is voltage, v1. If it is voltage, then this must be current, I2. If it is current, this must be voltage, v0. Okay, so just like this: voltage, voltage. Okay, similarly here, just you write this is first branch. Just you see, forget this one. Okay, just is first branch is what? Impedance. So here it will come admittance, next branch. See, next branch is what? Next branch is capacitor, but it is connected in shunt. Whatever the branch that is connected in shunt, for that it will come. See, next branch is what? First branch is what? Resistance. resistance, this is resistance, then it is admittance, it is admittance. If first one is admittance, this must be what? Impedance. So this is what? Just impedance. Capacitor impedance is how much? 1 by sc, 1 by sc. Okay, so now if it is impedance, this must be what? Now this must be admittance, this must be admittance. Now next one is what? R2. For R2 admittance is what? Nothing but 1 by R2, 1 by R2. Now if it is admittance, now this should be what? This should be impedance. Now next one is what? Inductor impedance is what? SL. This I have, this we have done this what? Indirectly. Okay, so indirectly from writing, just seeing this each component. Okay, so now we are going to feel what? We are going to give the, we are going to give feedback to each node, feedback to each node. See for I1, for I1 node, for I1 node, if you see here, there is no feedback for I1. Okay, so it is like open, no feedback is there. If you see for V1, which one feedback is there? Just if you see for I1. Okay, so see for I1 feedback is what? Feedback is nothing but it's previous, this one. Okay, so this one, previous one is the feedback. So it will go like this. Okay, feedback is what? First one is what? Admittance with negative feedback. Admittance with negative feedback means minus 1 by R1. If it is admittance, next one should be impedance feedback. What is next one? Impedance feedback. This capacitor impedance is nothing but with negative feedback 1 by SC. 1 by SC. Now if it is impedance, this should be what? Admittance. This feedback should be admittance. What is next? R2. So negative feedback by R2. Okay, so now just this is what? This is the what? This is the trick. This is the trick and shortcut. Okay, so this is what? Short way means short trick. Short trick means this is just by understanding. Just give the idea. Just see this network. Okay, so how many number of element? 1, 2, 3, 4. That many node? 1, 2, 3, 4. Okay, alternate. What is input? Voltage. Then it is current. Voltage. Okay, alternate. Now just fill this. First one is what? First one here will come admittance. See, this is resistance, this is admittance. Okay, it will come admittance. This is admittance, then it is impedance. Impedance. Okay, alternate. Impedance, see, admittance, impedance, impedance. Then in feedback, see here for this feedback. For current I1, R1, for current I1, 1 by R1. Feedback. Negative feedback, admittance. Here for V1, negative feedback is impedance. Here for I2, negative feedback is admittance. Alternate. Admittance. Similarly here, admittance, impedance. Like this. Okay. So now we are going to see, try if you want to become much comfortable in this type of network, just you write this. See, register. Okay, register here. Resistance, this is my capacitance. Okay, so this is my resistance, this is my capacitance. Okay, so this is my again resistor, this is my inductor. Okay, so inductor. Now this is my output voltage, V naught, positive, negative. This is L, this is my, let's say this is R3, this is C2, this is R2, and this is C1, this is R1, and this is my VI, positive, negative. Okay, somewhere here is ground. Okay, so this is my ground. Now see, now just write signal flow graph for this without writing any KCL KVL equation. Okay, so just write what? Signal flow graph. How we can write signal flow graph? Just count the number of electrical component. How many? 1, 2, 3, 4, 5, 6. 6 node. Then write here 6 node. 1 node, 2 node, 3 node, 4 node, 5 node, 6 node. Yes, 6 node completed. For input, separate node for input. Okay. Up to this task is over. Now, what is our next target? Next target is, sir, see just input. Input is what? Voltage Vi. Voltage Vi. Input is voltage Vi. Okay. So now this, if it is voltage, then this is what? My current I1. Yes, this is my voltage. Then next one is my voltage V1. Next one is my current I2. Okay, so next one is my voltage again V2, and next one is my current I3, and next one is my voltage V0. That's it. Okay, so this is what? Voltage, current, voltage, current, voltage, current, voltage. Okay, alternatively. Now see, now we are going to write. This is my voltage Vi, current I1, voltage V2, current I2, voltage voltage V3, voltage Vi, current I1, voltage V1, current I2, voltage V2, current I3, voltage V0. Okay, so that's it. Voltage, voltage. Okay, so now this is my gain. Yes, gain. Now gain we will write. Now see, gain. First one is what? Admittance, right? Admittance is what? 1 by R1. 1 by R1. If it is admittance, impedance is what? 1 by SC1. 1 by SC1. Okay, 1 by SC1. Now impedance, now it is admittance R2 1 by R2 1 by R2 1 by R2. Okay, now admittance, impedance 1 by S, impedance of C2 is what? 1 by SC2 1 by SC2. So just write down 1 by SC2. Yes, now admittance 1 by R3 1 by R3 1 by R3. Okay, now admittance. This is my impedance is what? Inductor SL. Okay, what we have done? Nothing. Just we have right. See here, admittance, impedance. That's it. Now just write what? Write feedback. See here, for I1 feedback is what? Admittance of what? First element minus 1 by R1. This is my admittance. Now it is impedance, negative feedback. Next element, impedance minus 1 by SC, 1 by SC. Now this is my impedance. Now it is admittance of this one R2 with negative feedback minus 1 by R2. Yes, this is what? Admittance. Now this is impedance. How much? Impedance as C2. So this is minus 1 by C2. This is C1. Now impedance. This is my impedance. Now next one should be admittance. What is admittance? With negative feedback R3. So minus 1 by R3. 1 by R3. So this is what? This is the way of what? Way to write directly. Yes, to write directly. Similarly, block diagram also. This is what? Vi, and this is my summer, and this is my 1 by R1, and this is my gain of what? Gain of 1 by SC1, and this is my feedback, negative feedback gain with what? With 1 by R1. Similarly, this is my next. This is SC1, V1. Then there is what? There is summer. Okay, and here is my gain of what? Gain of 1 by R2, and here negative feedback is what? 1 by SC1, negative feedback. And next one is what? Again gain of what? Gain of 1 by SC2. Yes, and this feedback, negative feedback. How much? 1 by R2, negative feedback. Yes, negative feedback 1 by R2. Similarly, next one is what? R3. Yes, applying to summer, and this is my R3. 1 by R3. 1 by R3, and here negative feedback how much? 1 by SC2. 1 by SC2, and this is my 1 by SC2. 1 by SC2. Yes, and next one is what? Again here summer, 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 and gain. Last one is what? SL gain. Yes, and here negative feedback of what? 1 by R3. 1 by R3, negative feedback. Yes, and this is my output V naught. So this is my block diagram, and this is my signal flow graph. Representation for this electrical network. Now I think now we are very much comfortable with this type of network, electrical network. Just you have to count number of electrical element. 1 2 3 4 5 6. Then node is how many node? 1 2 3 4 5 6. 6 node. Okay, and separate for input. Okay, so that's it. Next one is what? Next target is what? Next target is just writing every node with current and voltage alternatively. First voltage, current, voltage, current, voltage, current, voltage, current. Like now, after that we have to write gain, forward path gain and feedback path gain. Both gain are either in impedance form, either in admittance form. All are in alternate form. Alternate form. First is impedance. See, first R1 impedance capacitor first is admittance. R1 admittance, then impedance, impedance, like this is what? Admittance, impedance in forward path, then in feedback. See, feedback, this is admittance, okay. See, admittance, okay. So that's it. So this is the way to visualize it properly without writing, because first general method is required, because until and unless then only we are able to understand it. Okay, so now we are very much comfortable that signal flow graph and block diagram is nothing but this is just the forward path gain and feedback path gain is nothing but either admittance or impedance, where each node is either current and voltage in alternate form. Okay, alternate manner. So this is the way of doing this electrical network in block diagram and signal flow graph. Okay, so that's all for today, and thank you very much. Okay.